Good evening, everyone. Thanks for joining us for another awesome vBrownBag have flyby to celebrate how happy we are that we're getting kicked off with infrastructure as code. Grant Orchard is joining us, and we're pleased as pie to have him.
Thank you very much.
So a few quick notes and housekeeping before we get started. We love to keep vBrownBag a conversation. So tonight I have co-host Angelo Luciani manning Twitter. So if you type hashtag vBrownBag into a tweet, you can ask questions, make any snide comments you want, and we'll make sure that they get read on the air and we can get you squared away. We're tweeting at vBrownBag, and we have Latin America and Europe handles with LATAM and EMA. vBrownBag US happens at this time every week, but we're not the only show. You can go to vbrownbag.com/brownbags and find a updated list of all of the upcoming shows that we're going to be doing. So with that, I'm going to hand it over to Grant. Grant, do you want to introduce yourself while I hand you control?
Yeah, sure thing. So Grant Orchard, I'm a 5-year veteran, I guess, of being with VMware, and my role at the moment is as the cloud management technical lead for APJ, which is Asia, Pacific, and Japan. And as you heard, my house, which is on the outskirts of Sydney, is within a reasonable proximity to one of the Air Force bases. So we may have, it sounds like a few more flybys this afternoon.
Just tried to time them for a dramatic pause or whenever you're trying to get some effect going.
Oh, that's funny. So the last time I actually did a vBrownBag as the presenter was with Alistair, probably about, I want to say 3 years ago, doing one of the VCAP design sessions. And the moment that plane went over, I was like, hold on, this is massive deja vu. This happened the exact same thing 4 years ago. And I was madly hitting mute, trying to break it up and the plane would go over.
Right. Yeah,
anyway,
screen. So you're good to go, man.
On with the show. Perfect. So what I'd like to do today is run you guys through a little bit more around what we can do with Terraform, providing infrastructure as code from the context of the vSphere admin. And I know we've had a couple of sessions on the brown bag covering off, I think, Git user management not that long ago, as well as, a very similar topic, an introduction to the vSphere provider for Terraform. So I'll try and skim over some of the introductory topics a little bit quicker today and jump into, I guess, some more, I won't say advanced use cases, but digging in a little bit more to how you can more broadly make use of this capability. So I'll spend a little bit of time on the differences between the prime constructs, which are the providers, resources, how we manage external data that we don't actually want to manage, funnily enough, using that word, but that we want to interact with, that we want to be able to get data from and then manipulate and use within our own definitions. Take a little bit of a look at how dependency resolution actually works with Terraform. And then we'll skip into, I guess, more of the meat that I really want to cover off, which is how you can make use of variables so that we can use dry principles, don't repeat yourself, as well as, getting beyond just the standing up of the infrastructure as code, but then how we can tap into some in-guest operations to provide a bit more customization, sort of post-provision. So a little bit about the structure of a provider. You can see here that we've got a typical stanza. Now, I did say that you should be able to see my mouse, so hopefully that is actually showing up. But the provider is always going to be called, the name actually of the technology provider. So it's going to be, for us, it's going to be vSphere. You might have AWS. You might have OpenStack. And then within that stanza, there are going to be a few things that are actually required for you to put in order to interact with that. So typically, username, password, the endpoint, which in this case is our vSphere server. And in most cases, we see that providers have the capability to say, hey, yeah, I'm using a self-signed cert, so please don't, have a hissy fit about the fact that this isn't using a trusted root or something like that. Now, if you want to take a look at providers, I think officially Terraform's sitting around somewhere about 75 different providers at this stage. So they've got quite a lot of coverage in terms of the wider ecosystem. And one thing to note, I think it's important, we talk about infrastructure as code, but when you go and look at some of these providers, they've got SaaS in there. So VMware's Wavefront, there's actually a provider for that that allows you to create dashboards and identify metrics and alerts. They also tie into PaaS. So, whether it's a PaaS-centric cloud like, say, Heroku, or whether it's actually more PaaS services such as RDS off AWS, there's also the ability to interact with those. And you can mix and match, right? So it's not a matter of a definition only works for vSphere, and I'll show you a little bit later on how we tie together both vSphere and some of the stuff from AWS. So if we then move on to resources, this is a very simplified example of what a vSphere resource might look like. So you'll notice the naming convention is actually fairly important to look at here. So a resource will always be called resource, and then the very first, I'm not even sure what we'd actually call that. Let's call it an octet, as if it's like an IP address, but it's always going to reflect the name of the provider. So vSphere resources will always start with vSphere and then underscore, and then it will be the actual name of the resource that fits within the provider schema. And then finally, we've got the name of the resource that we want to use within our description. So in our definition, whenever I say TF-01A, and I'm not doing any kind of, here we go, interpolation down the bottom here, I'll actually, that's not interpolation, sorry, my bad, that's just a string, ignore that. But I can actually have that as a reference. So if I want to have more than one virtual machine, I might have TF-01A, and then a second one would be O2A, and then that's the short name that I can refer to these objects as within my definition. Now, one thing that you will note here within my resource is that I do have some interpolation occurring from a data source. So we'll take a look at how data sources actually work next. But the idea there is that we can actually grab data from them rather than having to hard code values. Going and actually looking up the MoRefs, or going into the mob and actually having a look at what those IDs are. It's definitely valid and you can do it, but it just simply doesn't scale very well. It's a lot of administrative overhead. So we want to find a way that we can actually get values for things like the resource pool ID that we want to use, or the data store ID, without having to go in manually and actually get those. So data sources, also colloquially external data. These are actually looked up by name. So yes, you can find yourself in an interesting situation whereby if you have similarly named clusters or the same names for particular clusters or data centers or whichever resource, you may find yourself getting into a problem. However, having said that, it's a nice, easy way to find yourself being able to look up. So in this case, we have the resource pool that I'm looking up. And if any of you have used the hands-on labs, this is actually baked out of the hands-on labs. So we look at our data center first, which is region A01-compute, and then /resources. So the resource pool in this case, we're actually looking at the root resource pool of the cluster, as opposed to a resource pool that we've actually created. Now, just to make things a little bit more confusing, or maybe make even more sense of them, we can also have lookups for data sources within data sources. So in this case, we're saying, right, I want you to query this particular resource pool name from within this data center ID. So within a proper definition, I'd actually have a resource, a data source defined for our vSphere data center, with the name actually being region 01A, or whatever it might be. We'll have a look at that shortly. All right, so I'm just going to cut over to a demo really quickly, show you what the definition is actually going to look like in practice. And we'll kick off the provisioning, but I'd say we may not actually wait for that to spin up. So here we have our base definition. And for those of you who are actually thinking about practical usage of this, you're never in your life actually going to put clear text, stuff like usernames, passwords, and probably even your vSphere server in your definition. And we'll look at that momentarily when we get to using variables. Now, as I mentioned, we've got a data source here of type vSphere Data Center. I've called it region 01A just because that makes it easy, because it's the name, and I can correlate in my mind strongly between the actual name of the data center and the name of the resource. And then we start bringing that through to all the other pieces that we actually need to discover. So it may be that when you're actually instantiating constructs within vSphere, that you don't just want to provision a virtual machine, right? You might actually want to be provisioning a resource pool or provisioning a data store, or for that matter, virtual switches, port groups, so on and so forth. I've tried to keep this relatively simple so as not to have to get too much into the schema of those constructs. But in this case, we're able to very easily discover those. And then when we actually get down to the point of provisioning our virtual machine, we can refer to those data sources by interpolating those values through. So when we look at our virtual machine construct, the resource has quite a bit of data to it. Now, this isn't necessarily going to always be the case. When we look at instantiating a virtual machine by the API, all this information needs to be provided. So, there's some stuff that we can abstract away through infrastructure as code, but, we can't get away from providing mandatory data points in order to, try and simplify this. If we have time at the end, I might talk a little bit about modules and how we can actually simplify the consumption of some of this. But for the time being, let's just assume that you need to specify all of these. So the one thing I would like to focus on a little bit is sort of here from line 75 down. What you'll note is that I've said clone. And what that means is then instead of just doing a typical create of a virtual machine and relying on Pixie or some other mechanism to stand this up, we're actually going to clone from an existing virtual machine. So you can see here, I've made use of a data source of type virtual machine. It's based Linux CLI ID, which we refer to. And then we pass through customization options. So exactly like you would if you're doing a right-click deploy from template and you say, yes, I want to pass through customization, these values can be codified here. And once again, just to be clear, I'm using static values here for two reasons. Number one, because I don't want to have to cover off too many explanations at once within each step of this. But secondly, it's actually really useful when you start to work through Terraform to start simple, right? You don't want to be troubleshooting, oh, have I mucked up, the actual definition? Am I using syntax incorrectly? Or is it a matter of me not having configured variables appropriately? So for me, I like to start this way, be very specific, and then become more abstract as I work through. And that's largely what we're doing through the course of today's presentation. All right, so let's flip over to here, which is the directory that I've got the definition in. So we can actually see that there's just a base Terraform file in there. Now, as always, the first thing you actually want to do is an initialization, just to make sure that you've actually got the most up-to-date providers, or if you're using modules pointing out to GitHub as the source, just making sure that everything is actually as anticipated. So I can do a Terraform plan at this point in time. It's going to go through and refresh basically anything that it knows about the environment. It's going to go and collect that data so that when it then tries to instantiate, those things are actually propagating through correctly. This will spit out momentarily. Bang. All right. Now here you can see everything basically that's going to happen. We can see that there are a few items that are coming through that are being specified, that actually been hard-coded. There are some things like, in this case, what it looks like in terms of the share count that's going to be computed when it's actually provisioned and implemented. So to actually make this go ahead and provision, I would go ahead and do Terraform apply. And because I don't want to have to confirm it, I'm just going to do an auto approve. and that will actually go off and instantiate. Now, I'm not going to keep you guys sitting here watching a terminal while we wait for that to provision, but I'll just wait for it to kick off so you can quickly see what that's actually going to look like. You can do it. This is like the little engine that could. There we go. So once again, it just spits out the exact same detail from your plan, and then it will actually initiate the provisioning. So here we can see it's actually going to track the fact that this is actually standing up. So you'll get feedback continually. I want to say every 10 seconds, but it's dependent on each implementation of the provider as to how often you're actually going to see that coming back. All right, so back to, all right. Moving on to dependency resolution. So I find this one actually quite valuable, especially if you're working in a team, if you've got some other people who provided you with parts of your definition or modules that you want to use. Understanding what's actually going on, you can spend a bit of time reading through the code. For me, I'm more of a visual person, right? So I like to actually be able to see what the dependencies look like in order for me to grasp what's going on. So there's a tool that's called graphviz, which you can use. And that ties in nicely with the idea of Terraform graph. So Terraform graph is a command that we can issue that's going to spit out all the dependencies, basically using a map to look at what relies on what and how this is all going to instantiate. We can then actually write that out to the dot file, and then we can use graphviz to convert that dot file into an SVG that's actually going to be something we can look at and view. So what I'll do, and we'll just make sure, it's been a little while since I've issued this command, so I'm just going to do the sneaky thing here and actually copy it. Okay, so okay, what are we in? Number 1. All right, so I think we have Terraform graph out to graph dot dot. And then if I spit that out and convert that, what have I done? No, it's out to graph dot dot, that's why. This is the problem when you copy and paste. Okay, sweet. Now in Sketch, we can see that SVG files actually just come through there. I'll open it up, and here, I'll try and zoom that in a little bit for you all to make sure you can actually see what's going on. But you actually get a really good visibility. And I mean, this is just a simple example, right, of what a single machine is actually relying on. So all of our data sources are relying on being able to capture the data center ID. And then once we've got those, we're actually seeing here's our virtual machine, which is relying on each of those to become available. For a simple virtual machine on its own, this is somewhat valuable, but it's really when we start to look at more complex topologies where we might actually be creating networks, where we might have multiple machines, and we're trying to figure out why we're hitting a race condition, or do we need to have explicit dependencies mapped through from one resource to another. Really, really useful. And I actually make use of this a lot with more complex deployments. Okay. So moving on to variables. Variables aren't, particularly different, regardless of whether we're looking at them within, different programming languages. Largely, they fall into one of 3 types, although, we have different names for them. So in Terraform, we have strings, right? So if I have a variable, which I've called var.string, if I actually try and, return that, it's just going to have, that's what it looks like. It's just simply a string. If I define a list variable, and in it, square brackets, comma separated, this is a list. I can do things like, returning based on index and position. I can muck around and do some other clever things, which we'll get into shortly. But, these are the different types of things that we've got. The final type that's of interest to us is a map. So I can say, this equals a map or foo equals bar, and then I can do things like looking up. So I can say, in this case, I want to have my variable, which is called map. I want to look up foo, which is this particular value here, and that's going to return bar. Now, a practical use for this is going to be, if you wanted to have a Terraform definition, and let's put it within the context of vSphere, there's going to be provisioning to multiple vCenters, or even to multiple data centers, right? You might have, you know, a particular network that you have, you know, different tiers of application actually land on, and unless they're stretched between the two data centers, they're going to be different values. But you want to make sure that your Terraform definition can actually apply across the board, right? So that it doesn't matter whether you're deploying to data center A or data center B. You might create a map that's called, let's just pick one, random SQL network. And for data center A, SQL network is actually equal to VLAN 103, but in data center 2, it's actually equal to TO203. So when you define where you're actually provisioning this to, you can say, right, I want to look up based on the data center that I'm provisioning this to, what should the network actually be equal to? So that's the value of a map within this case. Now, some limitations with this. When we look at maps, we can't actually nest lists within a map, which is a bit of a bugger. So when you try and do something like I've got on screen there at the moment, we can't do things like, hey, I want to look up this, you know, 0, which should be is, it would fail. If I do var map foo and look that up, that's not actually going to work. We can't use that whole concept of an index within a map. So there are ways around that. And the way that we actually do it is by getting a little bit clever. So we'll actually drop, for example, a string that's comma separated. So it's not actually a list, it's just a string, but we identify a character that we're going to use to separate out those values. And we make use of the split function. So I can say, right, what I want to do is split using the comma. I want to look up var.map, I want to look up this, and then what that will actually return is a list, right? So that we can then do some fancy stuff. So here's our initial statement, I guess, or how we're going to interpolate that with our syntax. It's mapped exactly the same down here. However, then what I do is I wrap it in an element and I say which is the element that I actually want to return from it. So starting at 0, 0, 1, 2, that would actually return string. So it does start to get a little bit complex when we want to do more clever stuff with variables, with lists, and have them sort of nested. There are ways around it, but you know, you need to decide whether you want to have, I guess, definitions and code there that other people can read and make use of. How comfortable you are with, you know, syntax like that, and how comfortable other people would be to actually use it, and you know, whether you want to go to something maybe that's a little bit more specific, a little bit less reusable, but a little easier to debug and understand.
So we actually have a question about the map, and
Sure.
Graham wants to know, is a map basically a hash table in that case? Or is it more like a dictionary?
Yes, absolutely. Yeah, it's more like a hash table.
Cool, thank you.
No problem. All right, so on to syntax testing. So, I mean, I just provided you with an example there. We're going to see how we go with me actually remembering where I put my variables. But let's actually look at using the console. Now, this is something that I actually make use of, again, an awful lot, because when I'm trying to get clever and concatenate things and split things and you know, do other sorts of things where it's like I've got two lists and I want to be able to compare, you know, both 0 items in the array to see what they look like. Putting all that together and then having to plan and hit the apply before things fail is a real, you know, time waster, and it kind of makes me cry a little bit. So what I'll do is actually make that a little bit bigger. And let me change directories to where do I want to go? There. And just excuse me for a moment while I actually cat out something. What have I got in here? Okay, there we go. So as an example here, let me just pull this up. So if I do Terraform console, what I'm able to do is resolve very quickly and easily what, for example, if I came in here and just do web port grip, unknown variable access, look at that. This is one that I should have practiced before I came in here for you guys, isn't it? Let me do it that way. See if it actually interpolates it. Well, that's a bit embarrassing. All right, let's do instead a lookup. Web port group, and that should actually return. Oh man, I'm struggling here. Sorry guys, that's terrible. And this is why you actually need to make use of this tool. So look, let me come back to that one shortly. But what I'll do, basically, it's a really handy way, unless you're using the syntax all the time, which, as you can see, I've been away from this for about 3 weeks now. You start to forget how you actually want to have all of those actually working together. So the trick is, if you come in and you can actually make use of that to debug and look at, okay, how do I string together, some fairly complex or trickier examples. And let me see if I've actually got one in. Where has it? Here we go. A slightly better example. Okay, so there we go. So we're in 3. Let's do that. Now, it won't know what the count index is, so I'm just actually going to put a value in there and actually need to open the console. So you can see that actually returns that back. If I was to change that to a 1, it changes the value as well. But again, if we start to say, right, so what was the example we just used? So if I said element of, that actually probably, this actually isn't going to work because it's not a string. But if we imagine for a moment that was a string of comma-separated values, then I could actually run something like this and it would return the exact same thing as we have here in terms of indexing. And again, as we start to do things like concatenations and mucking around with string manipulation, actually having the console there so that you can try it out, and then once it's finally working, you can drop it back into your definition, that becomes an awful lot easier. All right, exit. Right, so now that we've actually spent a little bit of time there on variables, what I would like to do is show you a bit of what it looks like in practice. Now, what I've done here for our second one, if we compare it to our first definition, all we had was that base TF file, right? When we come to using variables, you don't actually need to split out everything into separate files. Terraform's just going to read in anything that has a TF extension. And for me, it just becomes a little bit cleaner and easier for me to come in and go, right, I'm going to actually declare my variables in a variable file so that they're not cluttering up my base definition. And the types of things that we can do with those variables is not only just put in a useful description, we can declare the type so that if somebody was to try and push, I don't know, a string into something that's expecting a map, it would come back and say, actually, no, sorry, you need to provide this in a particular format. If we come down a little bit further, we can actually do things like assigning default values. So a good example of that is, that allow unverified SSL for self-signed certificates. My default value is true, so I don't need to specify that in my definition if I don't actually want to. I can just go ahead and it will read in the default value and make use of that. Same here, so other examples, I've put in here a default value for our virtual machine prefix. I've created some, I guess, abstractions for when I'm talking about what I want machine resources to look like. So if you say small, it just translates to 1 CPU and 2 gig of memory, and so on and so forth. And here we go. This is actually the example that I was meant to be using for you guys. We will come back to that, I promise you. So let's then take a look at how we change our base definition to take example of it. All variables start with our var, and we drop that in there. It just means that I can reuse this really, really easily. I can start doing things like saying, right, regardless of this being used for a different application stack, I can grab the exact same definition that I've got. I can change the variables, and somebody's already done the hard work of actually creating the entire definition. Now, what I'll do is just switch over, not to that one. In fact, let me actually go back to 1 and get rid of what we've already done. And then over here, I'll come into variables. Now, the one thing that I haven't covered off here, which I will as soon as I type this in, if you don't actually have a default value or you haven't specified it within your variables file, it's going to prompt you to say, hey, what are the values that you actually want to use here? So that's one way that we can do things securely. The other option is that we can actually store environment variables in a resource configuration file or an RC file, the same way as you would for your bash profile configuration and so forth. So if I went back, and I think I've got that in there, I can run the exact same command again, and cleverly it just reads that through. So that's a nice way for us not to actually have to store credentials and things in our variables file. So it's going to go off and run. Oh, no, it's going to fail. Look at that, I should have tested that one as well. Sorry, guys, this is very poor form. So we can see here that, to the exact point of what I was saying before, when we look at what the variables are called and what type they actually have, is saying, right, we need to be providing this as a single value, not as a list. So if I came in and actually take a look at those variables, we probably see that the defaults are actually defined as a list or something like that. All right, let's head back over to...
We did have a question come in from Stephen Goodpaster. He says, can you use a secret server like Conjure or CyberArk for your passwords?
So I'm not sure if there are specifically providers for those two. However, what you can do is use Vault, which is another HashiCorp product. So that's one way that you can get around it. The trick is, and it's actually something that you really need to be aware of, is how you handle state, which is what things look like that's actually defined in code once it's provisioned, not your desired state, but the actual state, which is in that TF state file. That's going to have any of your usernames and passwords actually in clear text. So that's a problem, definitely, and we'll look at how we can go about securing that and getting that away from clear text files very shortly.
Thank you, Grant.
All right, so where did we get down to? Cut the demo, which I didn't do very well. All right, moving into provisioners. So far we've looked at the idea of instantiating virtual machines, cloning from a template, but that doesn't really give us a lot of control in terms of what then happens, after the provisioning. In this world, most people don't want to just request a virtual machine. What they actually want to say is, I need, an application stack, and I need you to provide that for me. So there's a few things that we can do with provisioners. So we have the idea of file, and all that is, hey, I want to copy something from, who knows, a local source or a remote source into the machine. That's done using SSH or potentially going via a Bastion host. For local exec, I've had a few questions about, why would you want to use local exec if you're performing tasks on a remote machine. So I've done some work with the OpenStack provider, and for those of you, and I'm sure there are many of you who've run nested environments before, you'll know that the distributed switches don't like having multiple Macs actually coming through, from that, and so you have to do some configuration to make that happen in terms of promiscuous mode. With OpenStack and the way the Terraform provider works, we can't actually pass through those extended values as part of that. So once I've actually provisioned networks, I then have to run, the Neutron CLI or the rather the OpenStack CLI these days, and actually have those changes made against my remote instance in order for things to actually come up properly. So that's an example of local exec. Remote exec is when you actually want to initiate a command from within the guest machine. And sorry, I didn't cover off Windows. Windows uses WinRM if you want to do this. So on a Linux machine, that might be something like, hey, I want to pull down scripts from GitHub and have those executed. It might actually be, wanting to register a machine to a Puppet Master and then hand over all the config to another CM toolset, Ansible playbooks, etc. Habitat I haven't used at all, but for the sake of completeness, I wanted to include that this is supported as a provisioner. And then finally, Salt Masterless is also supported as a native provisioner with Terraform. So what does the context of this look like? The first stanza that I've included here is how the connection is actually going to be handled. So, by default, when you use SSH, it's just going to look for a username and a password. When we actually use SSH, it's a lot more secure actually to make use of key-based auth, so that you're not passing that through and again storing those credentials. And all I'm doing here is with this interpolation, I'm actually saying read in from a file that's located in this particular location, and that's my private key. And then that matches the public key on the host side, and connection will actually work. Now, the idea of the Bastion host is that, we potentially don't have direct access to each of these machines just to SSH from, the rest of the world. So what if we actually hit a Bastion host and then have it jump to our new nodes and execute these commands or copy these files across? So it acts as that man in the middle, and is probably a far more secure way for us to be doing these kind of actions. Now, in this case, I'm using, yes.
Oh, sorry to cut in on you there, Grant. I just had a question from Steve. Is there a way to do remote execution via VIX API?
Not at this point in time.
Okay. Thank you.
Yeah, so this is, so to, I guess, clear this a little bit. So the provisioners are very generic in nature. So they're all, SSH or WinRM based. If you wanted to actually look at something like that, I'm just trying to think if there's a clever way. There is actually also a HTTP provider. I'm not sure whether or not it actually uses or allows for authentication, but we could look at whether or not you could do something clever with, the VRO run scripting guest to actually do something like that, or as you're probably looking for, triggering directly off the vSphere API to actually execute this. I'll follow up on that one for you and see if there's something smarter that we can do. All right, so this being a file provisioner, you'll see that we can specify a source and a destination for where those things are going to land. Now, syntax is, again, super important in terms of, what's going to happen with a trailing slash versus what's going to happen if we don't put one. So our source in this case is going to look for everything that's within that directory. If I left the trailing slash off, it would actually pick up the entire directory, not just the files, but the directory itself, and push that across. And then similarly with our destination, depending on whether we say, right, I want to, drop this into temp without a slash, or whether I want it to be temp, with a slash, so it then, either drops the files in there, or in the case of a folder, it actually, rather than creating that folder, it would actually drop it inside of that folder. So again, just syntax that you need to be aware of and think about when you're using this stuff. Right, so here's our remote exec. You'll notice that the connection side, the top half of that stanza looks exactly the same. The second half of what we can do then is have this inline list of commands that we're going to execute sequentially. So in this case, we can see here that we're doing things like just doing a find for a particular file type, changing the permissions on that. We're going to execute our install PHP. We're going to execute a number of scripts. And just to highlight, interpolation isn't just something that we can do within the resource. We can actually pull that through to the provisioner also. So in this case, we can do things like saying, hey, what's the name of our WordPress DB in this example? And I'm going to pass those through as arguments to my scripts in order to make sure that we're getting the appropriate data. And again, that same idea of how do we create and build reusable content rather than something that's very specific and tied to our one instance. All right, so we're going to cut over to another demo, which I'm going to confidently say will work much better than what we had previously. Not remote state, we want to go to provisioners. We need to have a look at that. All right. Now, if I just have a look at what we've got in terms of our state at the moment, there's nothing in there. So we've got an empty state file, which means although this has been provisioned in the past, it's actually been torn down and there's nothing actually in there. So I'm going to be brave and I'm going to do something you should never do in the interest of time. And I'm just going to apply it without actually planning. Now, just to talk to that, since I'm doing something you shouldn't do, the idea of planning isn't only about understanding what is actually going to occur within the environment. It's also a very good way for you to come in and go, right, if I do a plan now, I can actually output that plan to a file and know that regardless of any changes somebody else might make, I can come back in and say, right, I want to apply. I can feed in the file and it will simply apply those changes that I've actually captured at a known point in time, so that when you've got multiple people actually working on this, or if you just wanted to output a change to one resource from within the file, you can actually control that and roll out your changes in a very controlled manner, which is quite useful and a good way to sort of manage risk. All right, if I come back now to our definition, I'll just walk you through what we've actually got happening in this environment. All right, our base. All right, so first of all, I've got this commented out. We'll come back to that momentarily. In this case, I've got more than one provider, right? So I mentioned this at the beginning of the session, which is that I can actually make use of multiple providers within a single definition in order to get to the outcome that I'm looking for. So in this case, we've got vSphere. We also have AWS, and for those of you who saw the keys on stage earlier, I will be changing those as soon as we wrap up the call. I'm also using a DNS provider so that I can actually configure internal DNS. All right, so let's take a look at what that looks like right now. You can see, and you should be able to guess based on what I said earlier, based on the name. In this case, we're creating a DNS record set using the DNS provider. I'm passing through the idea of account, which is to say, okay, how many of these am I going to create? And I'm, in this case, passing through a variable that's called web cluster count. And then based on that, we're going to go through and create DNS records using our web prefix. We're going to format those to have 3 digits and then go our count index +1, because the count index will always start at 0. And then again, assigning the value of those, the IP address is going to come from our list of IP addresses and the count index that's associated with those. So the first record and the first name are going to match to the first IP address. So they're our internal. I'm doing the same thing for our database servers. If I come down here, I'm also, in this case, making use of the AWS provider, calling out to Route 53 in order to create a publicly resolvable DNS record, right? So in this case, I'm grabbing the public IP that's going to be used. Public in this case is a relative term. I'm connected in via the VPN to get to the back end of our labs infrastructure so that I can do this. And the public IP is actually just a 10.IP, but it allows me to create that record and resolve it from my machine without having to rely on VMware's DNS servers. If I then come in and take a look, you can see I've got a combination of hard-coded values here just to make sure this is all going to work as anticipated, as well as pulling through stuff, variables from our variable file. So here we've got a large combination of things actually going on. Within the definition of this particular virtual machine, we're connecting by SSH using the root user. Once again, you probably want to create appropriately entitled users, but for the sake of an example, using root is nice and easy for us. And this example is exactly what you saw from the presentation before, so I just actually lifted my own code and dumped it in there. So I'm copying some files up there and out of our scripts directory, which is sitting right here. And then I'm actually going to use the remote exec provisioner to basically run those scripts and configure my machines. So that's basically where we're at. All right, now let's go back and see how we're tracking in terms of provisioning at this point. All right, that's complete. So in theory, what I should be able to do right now is come back to a browser. I should be able to hit that, and boom, our WordPress app has successfully installed, and we can see that those virtual machines have actually been created here. If we look at our timestamps, that's me in my local time that those have come up. All right, so there's an application deployment. Again, when you're actually doing this probably more at scale and within production, you wouldn't just be using scripts to sort of say, here's what I want the internal state of the OS to look like. You'd be using CM tools and basically setting up your relationship and registration with those via some of those in-guest scripts with the remote exec. All right, so my final task for you to cover off today is to talk about remote state. I don't actually have a slide on that, but to the point earlier, how do we go about handling sensitive data since it's not actually hashed and needs to get read through? The other aspect and the other challenge that we face with a tool like Terraform and shared definitions is how do you handle the fact that the state file, which we can see here now, which contains all the information about what we've just provisioned. What's going to happen if, I don't know, Angelo decides that he wants to actually run this, and so he clones the repo down, makes a change, and provisions. Well, he's going to have a completely different set of data here. He might make changes to mine, and our state is not going to be consistent between the two of us. So what we need is a means of storing state remotely that we can both access, so that we're always going to be running from that consistent known state, and we're not just relying on that state being stored locally on our machines with sensitive data so that we can apply some controls around it. So doing this is actually super, super easy. As part of our definition, we can define what we want a backend to be. Now, in this particular case, I'm making use of console, which is service discovery and a key value store by Hashi. But I don't necessarily need to use console. I can also push that out to S3, and make use of that as a means of storing the remote state. So I've made a change to my definition. That's not going to automatically happen. I need to come back over to our CLI. And let's use the one I was in before. And if I was to now go Terraform init, it's going to go, hey, I need to, again, reinitialize the backend because you've made a change. So if I say yes, in fact, just to prove my point before I do this, I'm going to come in here and show you console and the fact that we actually don't have anything in here. That's completely empty. If I come in and say, yes, I actually want to copy it, then it's going to grab that state and it's going to push it across. I can come back here. Oh, what just happened there? I can come back in and there's all of our state, which is now stored here. And to make sure that we're covered in terms of, I guess, the benefits of doing so, it basically, the provider will enforce, or in fact our, having initialized that, it's going to enforce the fact that none of that state can actually be stored locally. So any changes you make, anything that goes on, the file will exist, but it will be blank, and there's not actually any data that's going to be stored locally. So really good way for teams to be able to collaborate, and for you to be able to apply your own controls and mechanisms about who can actually access those state files and the sensitive data that might be included within them.
Grant, I have a question on Twitter for you.
Sure.
Question from Ken on Twitter. Would all this vSphere Terraform goodness we've been learning about tonight work on VMware AWS cloud as well? Or is it using APIs that are not available on the service?
No, so the good news is all the stuff that you've seen right now definitely works with vSphere on AWS. Yeah, it's exposing everything that we actually need to be able to do provisioning, do the initial discovery, definitely.
Thank you.
Brilliant. All right, now I have, I've got 8 minutes left. I've managed to burn through that a little bit quicker than anticipated. But the one thing that I would like to sort of briefly touch on, and I don't have some examples here, but what I might do is find some resources to share as well, is the idea of modules, right? And the concept behind that is, if I actually want to consume this and I want to do some more clever rework, right? If we take a look at that example that we just looked at here, there's a fair bit of information. I mean, how many lines of code are we looking at there? 220, right? That's not horrible. But by the same token, for someone who's just getting started with this, they might look at it and go, "Whoa, that's way too much. It's way too hard for me to be able to make use of." Now, in fact, I think I do have something I can show you here. Where are we? SG. Let's sort you by name. There we go. Boom. Oh, no, that's an older, oh, there we go, no modules. Okay, perfect. All right. So as an example that I'll show you here, we've got the idea that what I can do is, instead of actually having to completely define everything, what I can do is have sort of a master definition that's going to call out somewhere else. So I'm just going to switch gears very, very quickly, and sorry if you're not all familiar with the examples that I'm going to use here, but we're looking at some work I've done with OpenStack for one of our bio environments. And the idea here is that instead of having to pass through, a whole bunch of complicated data, I can just say, right, I need to create a resource using a module. So what I'm going to do is point that to a particular source. And in this case, the modules are all coming out of this particular directory. They could actually be stored remotely on GitHub. And in fact, Terraform have what's called a registry, where you can go and pull down a number of applications that they've already had people contributing and creating and using. But the beauty is that, rather than having to come in here for an example and import all of this data, I could just pull stuff through and say, right, I want an OpenStack instance that has this name, this particular image, this flavor, and it will go away and do the entire thing for me. And I don't have to worry about understanding, as an example, before I was telling you about some of the trickier queries to write up, having to figure out this and look at stuff like port IDs and port names, and then, compare those and match them and have these really long, complicated expressions. I can simply come back to a base definition and say, right, I need to point towards this module in order to stand up an instance, give the bare necessity information, and then let someone who's maybe a bit smarter or more experienced figure out what that backend needs to look like, which is really, really useful. So if I was to recommend to you guys further reading on this stuff, so there is the Terraform book, which we'll go to on AWS. Oh, Terraform Up and Running. Okay, that's a different one. But the second one that I was actually going to recommend, so Evgeny, who's done a lot of work with Terraform, and then we have Terraform book, let's be specific, James Turnbull. Awesome. All right, so these two books really are what got me up and running, if you'll forgive the pun, with Terraform. All of their stuff is around really AWS because they don't want to assume that you need to set up infrastructure on premises. But all the principles translate. All of the work around how you handle variables, elegant ways to handle reproducibility and don't repeat yourself. It all transfers really, really nicely into vSphere or to VMware Integrated OpenStack or to other providers that you might see coming out of VMware shortly. So with that, we're coming up to, I think, the end of our time. Got any last questions you want to throw out there, or shall we close it up?
I see a question from Stephen. Provisioners are good. Infrastructure as code is good. How do you make a portal for users to self-provision and generate the Terraform files?
That is a mighty good question. So a little bit beyond the remit of what we're covering off today. I haven't had the pleasure of working with Terraform Enterprise. I don't believe they have a design canvas, which I guess is where you're heading towards, that same kind of drag and drop that we have with vRealize Automation. That said, yeah, they have an enterprise product which has a UI, but I'm not sure whether it actually allows for that kind of experience. I think it's more targeted at teams of, I guess, app infra developers who are going to be working together on spinning out this infrastructure. So for a user, it's a bit more tricky. I think to do something like that, you'd need something custom, which then had just the Terraform binary sitting on the back end and executing the required commands. So that's not a great answer. I'm sorry, but yeah, I'd say watch this space.
That's more
and in fact,
that
might be a good question to throw up on Twitter and actually hashtag Terraform to see if we can get an employee or a HashiCorp employee to respond to.
Got it.
I think I don't see anything else on the internet, so I guess we can just say thank you very much. John Julio does say good stuff, Grant, and Larry Smith Jr. on Twitter said great job. So I will plug. I started working on a series for this, but I didn't want to get too far into it before I ran today's session. So I do have basically started writing this up, and I will hook into a Git repo. So if people want to start looking at how to follow along and potentially have examples that will work in a demo, then definitely take a look at that. I'll be pumping some more content up there for you guys this week to complement today's session. All right, great. Yeah, I'll make sure get all those links, your GitHub repo and this code series into the show notes when the show goes up. Thank you very much. Everyone's really enjoying it, saying it was a great session. We're excited to see where your series goes, and we'll make sure to get that tweet out to say, is there anything coming as you suggested? So, thanks everyone for joining us tonight. For vBrownBag, for Angelo and Grant, I'm Tom Green, and thanks for joining us. See you next week.